Do you actually need thermal paste on a processor? Well, that's an obvious answer to yes, you do need it. But there's quite a few people on the internet who've built a system, and on the forums, it might be the first system they've built, and they're going, whoa, my temperature on my CPU is like 80, 90 degrees. Why is this? I've not used thermal paste. It said something about that in the box. Should I actually be using it? And the obvious answer to some of us is yes, but if you've never used it before, how do you know it's actually meant to be used? Or what does it actually do? I think it makes it cooler, that's what you might be thinking. But how does it make it cooler? Well, in today's video we're going to actually explore the properties of thermal paste and do a few experiments on, on a CPU without a cooler, or with a cooler on without thermal paste, and then we're going to test a couple of different thermal pastes to see how that affects the temperature as well. Now, how does thermal paste work? Well, if you secure your CPU cooler onto the motherboard with direct contact with the processor, you think there's nothing in between that, we're going to get a nice clean transfer of heat direct from the processor into the heatsink. What we don't see is that human eyes aren't as good as we like to admit. We can't see microscopic things like bacteria, microbes, or oxygen for that matter, and there's plenty of little imperfections in the surface of the CPU and the cooler that oxygen gets trapped in between. Now, oxygen has really bad thermal compounds. It doesn't transfer the heat very well at all. And what thermal paste does, it's kind of like sticky liquid, a bit like maple syrup kind of consistency. And once it's applied to the surface of the processor, it irons out all those little imperfections so oxygen doesn't get trapped in, and allows a nice clean spread of heat going direct from the CPU into the cooler. So, without further ado, let's get into the experiment we got here. And on our test bench, we have a system set up. This is a pretty old system actually. It's a Core 2 Quad Q6600. But it's good for the experiment because we can overclock it by about 1 GHz to really try and ramp those temperatures up. So what we're going to do, we're going to start our first experiment with no CPU cooler at all and see how long it is until the system shuts down. So let's start off by, if our cameraman swaps places, and let's see how long, or let's see even see if we can boot into Windows, and if we can we're going to run some stress tests and view some temperatures. So here's going on the first go. Okay, let's see this boot up. Let's see if we can get the screen to post. Well, we have a green light, that's a good thing to have. Okay, it says no drives found. We have an overclocking fails, please run setup. Don't put the fan in the way of the keyboard. That's in there because the computer won't start our CPU fan on this board, so let's see why it won't start. Let's get our tools up somewhere. It's got system information. It should show us what our CPU temperature is, if the board's good enough. And there we go, it's dead. Okay, well that lasted for about, 1 minute without any heavy stress on the CPU, and it failed after that. So our next thing we're going to do is install a CPU cooler onto this without any thermal paste and see how that affects it instead. So what I've just seen then is the CPU get that hot that it just cuts itself off. Now Intel CPUs, if they reach like the high 90s in the temperatures, it will start doing something called thermal throttling. And that's where they bring the multiplier back, and in order to try and reduce the heat, it slows the clock speed down. Now if that continues to get hotter and hotter and thermal throttling doesn't work, the CPU will go into an automatic shutdown, and in order to save its life, it will cut itself off completely. Now some old AMD CPUs didn't even do that. They would just carry on increasing in temperature until they would literally explode out the board. And that'd be quite scary, and you wouldn't want that, but thankfully Intel ones are designed to be better than the old AMDs. Now that got so hot that then it cut itself off. Now no one's ever going to run a CPU like that, but it was just to show a comparison between what's come up next. Now the next thing we did was we attached the heatsink to the motherboard, and we didn't apply any thermal compound to it at all. Now the temperatures were quite scary what we actually got up to. We actually hit a maximum temperature of the average hours over all 4 cores of 96.5 degrees Celsius. And taking into account the CPU went into thermal throttling, reduced its multiplier down from 8 times down to 6 times. And this resulted in clock speed from 3.4 GHz down to 2.2, and it was still maintaining a high temperature. Now that's well beyond any comfortable level you want your CPU to run at. Now when it was idling it wasn't too bad, it's 52.5. That's still a high figure, but it's not worryingly high that you worry your CPU is going to be damaged. But the thing to take away from that is that it got that high under load that the CPU lost pretty much like 30-40% of its overall power. Now we applied some thermal paste to that, and we used a cheap generic compound which had been in my drawer for about 8 years and is most probably well out of date. When we did that, we seen the temperatures drop under load from 96.5 degrees down to 75. That's a massive drop of 21.5 degrees, and that's without going to thermal throttling. If the first test were no thermal compound on at all, if in that test the CPU didn't thermal throttle, I'm sure we'd have seen the CPU temperature rise and rise and rise to maybe 110 or 120 degrees Celsius. So the figure we've got there looks a little bit less than it actually is in reality. 75 degrees is perfectly comfortable for the CPU. A lot of users want to get a lower figure than that, but in reality the CPU is comfortable handling that speed and will continue to operate 100% efficiency at them speeds. Now under idle, the temperature dropped down to 42.5 degrees, and that was 10 degrees lower than what it was with no thermal paste at all. And automatically we can see that just a little bit of compound is making such a massive difference to the overall temperatures and overall long life of your CPU. But then finally for the final test we decided to go and get some MX4 compounds, and that was probably one of the best compounds you can get. It's very highly recommended and it's a bit more expensive than the other stuff. But the results are very, very interesting. We actually see with this new, fresh, high quality compound, we've seen the temperatures drop from 75 degrees with a cheap compound down to 70.5, and that's 4.5 degrees difference under load. And that's quite a big difference really, it's quite significant. And under idling it wasn't much, we cooled down by 0.5 degrees more. But still, it's a step in the right direction. And comparing that good compound to no compound at all, we've seen a difference in 26 degrees under load and 10.5 degrees when it was idling. So the results may not surprise you, but it is interesting to see how much of a massive difference thermal compound makes to your CPU. So the one thing to take away from this is don't skimp on your thermal compound. It really makes a difference to the overall temperatures of your CPU and the life of it. So unless you want your CPU to die a horrible death, I may not do that with cheap stuff, but if you really wanted to preserve the life of it, buy some good compound. It's definitely worth protecting that £200 CPU with £5 worth of thermal compounds. Anyway, thank you very much for watching this video. This has been our first video we've ever made, so we hope it didn't bore you too much. But if you liked it, please click the like button or click the subscribe. And if you've got anything to say, please leave something in the comment section down below. And we're really interested for any feedback you have. And we hope this is one of plenty of videos to come in the future. So thank you for watching, and we'll see you again very soon.